So today's lesson is on force based on Newton's law. To begin, Newton's definition of force is a push or a pull upon an object in result of its interaction with another object. For instance, as this image shows, when a football player kicks a football. As a player's foot comes in contact with the ball, it causes it to be pushed outwards. And this particular force is called applied because, as I said, the foot is applying force on the ball, causing it to move forward. So each time there is an interaction between two objects, a force acts upon both of them. So when this interaction stops to exist, they no longer experience force. In continuation, force is able to cause a change in velocity, furthering with causing acceleration. But there has to be an interaction because then the acceleration will be zero. So if there's no interaction, there will be no force and zero acceleration. So force can come in various forms, such as normal, applied, spring, air resistance, tension, and gravitational. So if there's more than one of these forces acting upon an object, then all those forces have to be combined to form a net force, given by the vector sum of all the forces, shown here. And according to Newton's second law, the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass depicted in the equation, as shown right here. So, when combined, these forces are separated based on x and y components in terms of I and j. So just to remember, when you're doing these steps, that the SI unit of force is Newton, symbolized as a capital M, or kg times meters per second squared. So just to go over some examples, I have here tension. As you can see, our object of interest is this, you can say, a lamp hanging from the ceiling. So over here is the force of tension, as a string is what causes this tension, as it's connected to the object of interest. But there's also a force of gravity, and we can say that this object is 3 kilograms. So what we're going to do is put these forces in terms of I and j. So let's start with tension. So this force is not going in the x direction, on the x-axis I mean. So this is just going to be 0I plus the tension is going in on the y-axis, so it's going to be ft hat. And in terms of gravity, it's not going in the x-axis, along the x-axis either, so that's going to be 0, and then negative, because it's going downwards in the negative direction, mg j hat. So now, since we have nothing along the x-axis, just cross this out and add these forces right here. So since we have the sum of the y forces, it's going to be the tension force minus mg equals ma. So we can plug in, since we know the mass, we can plug in 3 here, and we know that gravity is 9.8. So plug in 3 for m and 9.8 for g, and then 3 for mass, and then 0 for a because it's not moving. This is just in one place. So ft minus 29.4 equals 0. So you can just move this over, and now we have our tension force with the newtons. So to move on, now let's go on to normal force. So normal force, an object has to be acting upon another object. So here you can see that the normal force is going upwards because these two are equal and opposite forces. So Fn, in terms of I and j, is 0I again because it's not along the x-axis, but it is along the y-axis. But we don't know what the force is, so just name it Fn. And then Fg, the same as above. And we know that this object is still, it's not moving, and the mass is 5 kilograms. So let's just add all the the forces again with the normal force and the gravitational force. And again, this acceleration here is 0 because it's not moving. So once we move over this number, we're going to get the force, the normal force, the newtons. And also here we have applied friction, but just not to go into much detail. Let's just say this is on a frictionless surface. So here, let's say someone pushed this object forward. That is going to be called an applied force, and the force he used was 20 newtons. So this force is going along the x-axis. So we can name this as 20I hat, because this is I has to do with the x-axis, plus 0j, because it's not going along the y-axis. So we could just remember x. So, and again, normal force, we have that normal force because it's acting upon another object. Fg is the same as above. So once we get all these terms in I and j, again, like we did above, to do the same steps in order to combine them. And that's the lesson for today.